This meeting is being recorded.
Okay, let's start going over attendance here. Cassidy,
Here.
Alejandro,
Here.
Liliana, Lainey,
Here.
Cassandra,
Here.
Romeo,
Here.
Viviana, Brenda.
Here.
Viviana's here? Or Brenda's here? Brenda's here? Is Viviana here? No? Okay. Jasmine?
Here.
Okay, Josue,
Here.
Jade,
Here.
Valerie, Edsel,
Here. Right over here.
Joel or Joel, Monique,
Here.
Salvador,
Here.
Caitlin,
Here.
Kayla,
Here.
okay, Romeo Ramos, Paula,
Here.
Aaliyah, Ricardo,
Here.
Matthias. Okay, one more time. Viviana, Valerie, Romeo, Ramos, Aaliyah, Matthias. Okay. Sounds good. Oh, Valerie's here. Okay, let's see. Let me know if there's any questions on anything up to this point. First exam is all graded and entered. So that's good. Yeah, so let's just go over chapter 5 today. Okay, for chapter 7, you have a project due October 9th for chapter 7. So keep that in mind. I'll send out an announcement next week. But the project's already in the next module. And so just keep that in mind, that there is a project that's due on October 9th for chapter 7. So, and all the instructions are already posted in the modules. Okay. So hopefully the homework is going okay and everything else with the class. We are entering week 5 now, so hopefully all that administration stuff is behind us. Okay. Okay. Let me share my screen here.
We're doing module 4 today, right, Professor?
Module 5.
Oh, okay. Just wanted to make sure. Thank you.
Module 4 was the exam. Yeah, so okay, we're going to start with chapter 5 notes today. Okay, so measurement, we're going to go over measurement today. Okay, U.S. customary units of measurement. Customary units of measurement are famously used in the United States, which are the units we know as inches, pounds, etc. Oh, okay. Thank you. Okay. Someone, because I'm echoing. Where's the participants? There we go. Mute all. Okay. Okay. Measurement is a number that describes the size. Oh, here we go. Fun fact. There are two other nations in the country that use customary there are two other nations that use the customary system, Liberia and Myanmar, which may not be common knowledge. Everyone else in the world uses the metric system. We're the only ones that use the US customary measurement units along with those two really tiny countries. Okay, measurement is a number that describes the size of amount of something. Measurements are taken from many things like length, area, capacity, weight, temperature, and time. Okay, 5.11 is length. Length is the distance from one end of an object to the other end, or from one object to another. The system for measuring length in the United States is based on 4 customary units of length: inch, foot, yard, and mile. Below are common examples. The length of a piece of paper is 8.5 by 11 inches. The height of an individual is usually measured in feet and inches. For example, Fuzzy Wuzzy is 6 feet and 8 inches. An official soccer football field can be any length between 100 and 130 yards. Okay, 1 yard is 3 feet. When running, we usually say that we ran so many miles. Okay, Peter Piper ran 4.3 miles. Okay, equivalents. Okay, unit equivalents. 12 inches is equal to 1 foot. 3 feet is a yard, and 5,280 feet is equal to 1 mile. Okay, convert the following units. Okay, 9 feet into inches. So we have 9 feet. I'll go a little thinner on that one. 9 feet. Okay, and we're going to convert to inches. So we want inches on top and feet on the bottom. We want inches on top and feet on the bottom because we want to cancel out the feet. So this is going to be 12 inches to 1 foot. 9 times 12 is 108 inches. 108 inches. Okay, B, 7 yards to feet. 7 yards to feet. So let's do our conversion here. Okay, again, we want feet on top. That's what we want to end up with. And that's going to be 3 feet to 1 yard. Okay, cancel out the yards, and I'm left with 21 feet. Okay, okay, let's change this guy from feet to miles. So 12,356 feet to miles. So put the miles on top and the feet on the bottom. That's 1 mile is 5,280 feet. Okay, and so we're going to end up dividing. Okay, put that over 1. Okay, we're going to end up dividing the 12,356 by 5,280. So let's go to the calculator on that one. So the calculator over here. Okay, so 12,356 divided by 5,280 is about 2.34. So we'll say it's about 2.34 miles. About approximately 2.34 miles there from the calculator. Okay, what about yards to miles? We have 4,325 yards to miles. So these are yards. So I want to go to feet, and then I want to go to miles. So let's go to feet first. There are 3 feet in 1 yard. And then I want to go to miles. So there are 5,280 feet in 1 mile. Okay, so we're going to multiply by 3 and divide by 5,280. It's going to cancel the yards. The feet are going to cancel, and I'll be left with miles. So let's do that on the calculator. I'm going to take 4,325. Okay, 4,325 times 3 divided by 5,280, and I get about 2.46 miles. So approximately 2.46 miles. Okay. Okay, hardware store. has 2 sales on tubing. 3 yards of tubing A is on sale for $5.49, and 2 feet of tubing B is on sale. Price is $188. Since either tubing is acceptable for your project, which tubing is less expensive? So we need to get this in terms of what we call unit price. Okay, so we're going to take each price and divide by the number of units. Okay, so we are going to take 3 yards of tubing A, so $5.49 over 3 yards. Okay, and how does that compare to $188 for 2 feet? Well, the problem is that we're not comparing the same thing here. We need to have dollars to yards or dollars to feet. It would be easiest to go from the yards to the feet instead of the feet to the yards. I'd get fractional yards here. So what's 3 yards in terms of feet? How many feet is 3 yards?
6 feet.
No.
Nine, my bad.
Yeah, 9 feet, right? Okay, 9 feet. So this is 549 over 9. Okay, feet. Okay, and I want to compare that to 188 over 2 feet, right? So let's see what the unit price is on each of these. So 5.49 divided by 9, that's 61 cents. Okay, 61 cents per foot. Okay, and what's 188 divided by 2? I think that's what, 94? Okay, 188 divided by, oops, 188 divided by 2. Yeah, that's 94 cents per foot, right?
Professor,
Yeah.
your notes are a bit blurry, or at least the screen looks a bit blurry.
Oh, it does? Oh, okay. Is it blurry for anybody else?
Yeah.
Let me try to reshare. Is that better?
It's a bit better, but it's still blurry. My bad.
Let's try again. Any better now? Still blurry. Is it good?
It's okay.
Yeah, it's okay.
It's not great, but it does it, I think. At least for me. I don't know about Romeo.
Yeah, we're good.
Last thing, Professor, do you think you can slow down a bit? Because you do go a little bit too fast if possible.
Oh, sure.
And, thank you.
Okay. Okay, so it says, since either tubing is acceptable, which tubing is less expensive? Well, since we found the unit price, okay, it really would be this guy, this tubing is less expensive. Because each foot, yeah, exactly, each foot is worth 61 cents instead of the other one that's 94 cents. Okay, we good? Are we ready to move on?
Yeah.
Sounds good. Okay, weight. Weight is used to describe heaviness or lightness of an object or person. Weight is measured in the US customary system using 3 units: ounces, pounds, and tons. An ounce is the smallest unit of measurement for measuring weight, and pound is a larger unit, and ton is the largest unit. Below are some common examples: a quarter-pound hamburger at a fast food restaurant. A stack of 11 pennies weighs an ounce. A whale weighs about 200 pounds. Equivalent and conversion factors for customary units. 1 pound is equal to 16 ounces. And 2,000 pounds is equal to 1 ton. Convert the following units as stated. Okay, 72 ounces to pounds. So 72 ounces, and the abbreviation for ounce is OZ. Okay, period. Okay, 72 ounces. So I want to convert this to pounds. So that means that the pounds have to go on the top, which that's the abbreviation for pounds. It's libs, LBS. Okay, pounds. Okay, and so 1 pound is 16 ounces. Okay, 1 pound is 16 ounces. Okay. So we're going to cross off the ounces, take 72, divide by 16. And I get 4.5 pounds. Okay. Okay, 6,500 pounds to tons. So 6,500 pounds. Okay, we want to end with tons. So there are 2,000 pounds in 1 ton. Okay, 2,000 pounds. So I'm just going to take the 6,500 and divide by 2,000. Okay. So let's do that. 6,500 divided by 2,000 is 3.25. So that's 3.25 tons. Okay, let's do 114 tons to ounces. Whoosh, it's going to be a lot. Okay, or 115 tons to ounces. Well, the first thing I can do is get to pounds, and then I can get to ounces. So I want pounds on top and tons on the bottom. Okay, so 1 ton is 2,000 pounds. Okay, and then I want to go to ounces, and there are 16 ounces in 1 pound. So I'm just going to multiply 115 times 2,000 times 16. Okay, so 115 times 2,000 times 16 is 3,680,000. So 3,680,000. Okay, and what is that? It's not tons, it's not pounds, it's ounces. Okay, we good? Ready to move on?
Yeah. Yes.
Good. Okay, the post office charges 44 cents to mail an item that weighs an ounce or less. Okay, the charge for each additional ounce or fraction of an ounce of weight is 0.17. Okay, at this rate, how much will it cost to mail a package that weighs 2 pounds, 3 ounces? So I've got to take the 2 pounds, 3 ounces, and change it just to ounces. So we can measure this by ounces, right? So 2 pounds is, I want to change that into ounces. So there's 16 ounces in 1 pound. So that's going to equal 32 ounces. Okay, that's for the first 2 pounds, but then I have to add the 3 ounces on top of that. That's going to give me 35 ounces. Okay. So the first ounce, I've got 1 ounce at 44 cents plus another, what? Another 34 ounces at 17 cents. All right? Does that make sense? Okay. So let's calculate this out. So 1 times 0.44, that's just 0.44. What's 34 times 0.17? That equals 5.78 plus the 0.44 originally for that first ounce is $6.22. Okay. Okay, capacity. Are we good? Can we go on? Edsel, are you ready?
Sorry, just wanted to make sure the 44 and the 17 you got them were from the amount of prices the post office is charging, right?
The 44 cents?
Yeah.
Yeah, 44 cents for the first ounce.
Uh-huh.
And 17 cents for each additional ounce.
Oh, okay then. Okay, I didn't see that.
Yeah, so if I have to mail something that's 35 ounces, it costs more for the first one than it does for each additional ounce.
Okie dokie. I see what you're doing now. Thank you.
Okay. Capacity. Capacity is the amount of liquid that an object can hold. There are 5 main units for measuring capacity in the US customary measurement system: fluid, ounce; cup, pint, quart, and gallon. Note, ounce by itself is a weight and fluid ounce is a capacity. Sometimes the prefix fluid is not used when it is clear from the context whether the measurement is capacity or weight. Usually if it's liquid, then it's by capacity. Okay? If it's a solid, then it's by weight. Very confusing, just like everything else in English is confusing. But that's okay. We will overcome. Okay, below are some common examples. A cup of flour is used for a cookie recipe, a 12-ounce cup of coffee, a pint of beer, a quart of milk, or gallons of gas. Okay, 1 cup is equal to 8 ounces. 1 pint is equal to 2 cups. 1 quart is equal to 2 pints. And 4 quarts is a gallon. So the way we kind of look at this is we take our gallon, right? And in our gallon, there's 4 quarts, right? Each of these is a quart. In our quart, there's 2 pints. So each of these is a pint. Right? And in a pint, there's 2 cups. So each of these is a cup. And in our cups, there's 8 ounces. Okay, so each of these is an ounce. Okay, so if you're to repeat all of this, then there's in 1 gallon, right? In 1 gallon, you would say that, oh, there's 4 quarts. There's 4 quarts, or there's 8 pints, or there's how many cups? Well, there'd be 4 plus 4 plus 4 plus 4, 16 cups, right? Or 128 ounces. How did I get that? Well, that's 16 times. That's 16 times 8, right? Okay. So if I let each of these be cups, right? Each of these is cups. Okay, then 8 ounces in each cup. Well, you'd have 16 times 8. Okay, make sense? Okay, now they're all cups. Except for this guy up here. This guy's a cup. Okay, and if each of these has 8 ounces, then 8 times 16 is equal to 128, right? So there's 128 ounces in a gallon. So if you go and get a gallon of milk, and it says on it, oh, it's 128 fluid ounces at the store, then you're like, oh, okay, that makes sense, because 128 fluid ounces should be a gallon of milk, right? There you go. It's also 4 quarts, which is 8 pints, which is 16 cups. Okay. Okay, convert the following units as stated. 72 ounces to cups. Okay, so 72 ounces into cups. So I want cups. So how many ounces in a cup? Well, in 1 cup, there's 8 ounces, right? So this is going to be 9, and I'm going to put the fluid ounces. Okay, the fluid ounces there. So that, or oops, it's not ounces, it's a cup. Sorry, my bad. It's 9 cups. Okay, ounces to cups. We're already given ounces. We want to convert to cups. Okay, 5 cups to pints. 5 cups to pints. Okay, so how many cups are there in a pint? 1 pint is 2 cups. So divide 5 by 2, and we get. Let me just back up. Sorry, I'm gonna have to. Stop my phone for a second. Okay, that should be 2.5 pints. Let me stop the sharing here. Yeah, exactly. Thank you. Why won't it let me stop sharing? It's lagging for some reason. I think Zoom crashed on me, but that's okay. You can still hear me, you just can't see me. Let's see if we can get things back. That's really weird, because I should be stopped sharing right now, but I'm not. Okay, there we go, finally. Yeah, for whatever reason, Zoom locked up on me. Okay, let's bring it back. Okay. So while this is booting up, for those of you that this is your first college class, what's the main difference between high school and college have you seen so far in these last 4 weeks? What's the main difference there? The number one difference you're seeing? Maybe you can't hear me. Maybe you can. The spacing between due dates. Oh, okay, yeah, that makes sense. So more time between due dates. Okay. Is that good or bad? Is that a good thing or a bad thing? Or is it just different? Oh, set dates for exams and lessons, yeah. Oh, you appreciate it? It's kind of nice to see everything all at once, know exactly what's going to happen every day of every week, right? Flexibility on assignments. With college, once it's due, it's due. Okay, so high school, there's more flexibility, and college, there is no flexibility. That makes sense. Yeah, more personal responsibility on the student. I mean, there's more pressure at the high school level to get students to graduate. There's really no pressure here at the college level to push students through. So, just kind of nice. Okay, let's bring this thing back. Okay, is it gonna work? Yay, there we go. Okay, let's. Okay, so we have 2.5 pints. Okay, pints. I guess I could write it out instead of abbreviating it. Okay, pints. Okay, what about 7 quarts to pints? Well, it's very similar, 7 quarts. Okay, QT is the abbreviation for quarts. And we know that there are 2 pints in 1 quart. Okay, there's 2 pints for 1 quart. Quart is the bigger one, pint is the smaller one. Okay, half a quart is a pint. So this is going to end up being 7 times 2, okay, which is 14 pints. Or sorry, yeah, 14 pints. Okay, what about 22 gallons to quarts? 22 gallons to quarts, okay. So 22 gallons, and there are 4 quarts in a gallon, right? 4 quarts in 1 gallon. So this is just going to be 88 quarts. Okay, 22 times 4 is 88. And 1,478 ounces to gallons. Whoosh. Okay, well, we could go through all of that converting cup to pint to quart to gallon, or we could use the fact that I just did all the work for us and said, well, in 1 gallon, there are 128 ounces, right? Fluid ounces in 1 gallon. We kind of did that already. We said that there was 8 ounces in a cup, there's 2 cups in a pint, there's 2 pints in a quart, and there's 4 quarts in a gallon. So if you were to multiply all that up, you would get 128 ounces in a gallon. And so we just have to take that 1478 and divide by 128. Let's do that. 1478 divided by 128. And I'm getting about 11.55. I'll say 11.55, and this goes to gallons. Okay. Okay, Lemoncita is making lemonade. Imagine that. Okay, to bring to the beach. She has 2 containers. One holds 1 gallon and the other holds 2 quarts. If she fills both containers, how many cups of lemonade will she have? Okay. So 1 gallon is how many cups? Well, 1 gallon, okay, is equal to 4 quarts. Well, let's do the conversion. Okay. So there's 4 quarts in 1 gallon, and there is 2 pints in 1 quart, and there is 2 cups for 1 pint. Right? So this is going to be 4 times 2 times 2, that's 16. 16 cups. 16 cups in 1 gallon. Okay, so that's the gallon. What about the 2 quarts? The 2 quarts. The 2 quarts. 2 quarts. Okay, 2 quarts, and then we're going to do 2 pints in 1 quart, and 2 cups in 1 pint. Okay, so 2 times 2 times 2, that's 8 cups. Okay, and we're going to add those together, and we'll get 24 cups. Okay. Okay, so that's the wacky English system.
Wait, how did you get the 24 again? Sorry.
I added the 16 and the 8.
Where's the 16 coming from? Sorry, I don't see it.
This 1 gallon is 16 cups.
Oh, okay, I see it from the other one. Okay, got it. I missed that part.
1 gallon and 2 quarts.
Okay, thank you.
Okay, 5.2 metric units of measurement. In the United States, both the U.S. customary measurement system and the metric system are used, especially in medical, scientific, and technical fields. In most other countries, the metric system is the primary system of measurement. Unlike the U.S. customary system of measurement, the metric system is based on tens and multiple or powers of 10. The metric system uses units such as meter, liter, and gram to measure length, liquid volume, and mass, just as the U.S. customary system uses feet, quarts, and ounces. So length, liquid volume, and mass. Okay. Okay, so for length, it's the meter. For mass, it's the gram. And for volume, it's the liter. Okay. The prefixes, okay, the meter is just, think of that as 1. Okay, 1 of something. Deci is 1/10. Centi is 1/100th, or 1 over 10 squared. And milli is 1,000th. Okay, 1/1000th. Okay, this would be 1 over 100. Okay, 1 over 100, and this is 1 over 1,000. Okay. 10 meters would be a decameter. 100 meters is a hectometer, And 1,000 meters is a kilometer or kilometer. Okay. Which of the following sets of 3 units are all metric measurements? Okay. Which of the following sets of 3 units are all metric measurements? Well, the foot is not a metric measurement, so I can get rid of D. Okay. The yard is not metric. Okay. The kilometer, centimeter, and millimeter, yeah, that works. The kilogram, the gram, and the centigram, yeah, that works. So, looks like it's B and C there. Okay. Convert the following units as stated. Okay, 1 kilogram to grams. So I want 1 kilogram to grams. Well, there are 1,000 grams in 1 kilogram. 1,000 grams to 1 kilogram. So there's 1,000 grams. Okay. Okay, 1 centimeter to kilometers. Okay, so 1 centimeter. So 1 centimeter is 1/100th of a meter. Okay. And 1 meter is 1/1000th of a kilometer. Okay, so let's see how this would play out. We have 1 centimeter, and we want to convert this to meters, right? So there are 100 centimeters in 1 meter. And there are, we want to go to kilometers now. In 1 kilometer, there's 1,000 meters. Okay. So what we're going to do is we're going to end up dividing 1 over 100 times 1,000, which is 10,000. You just kind of add the zeros there. Okay, I'm sorry, it's 100,000. Okay. So this is 1/100,000th, okay, of a kilometer. Or if you wanted to put it as a decimal, that's going to be 1, 2, 3, 4, and then a 1, I believe. Tenths, hundredths, thousandths, 10,000s, 100,000s. Yep, there's four leading zeros, and then that's kilometer. Okay, so it's 0.000001 kilometer. Okay. Okay, what about hectoliter to milliliters? Hectoliter. So 1 hectoliter, okay, is equal to 100 liters, right? 100 liters. Okay, so I could make that a conversion. Okay, 1 hectoliter is, okay, 1 hectoliter is 100 liters. Okay, and we want to convert that to milliliters. Well, there's 1,000 milliliters in 1 liter. Okay, and so what we're going to do is just multiply the 1,000 times 100. So there's 100,000. And what's the unit we're left with? Well, it's milliliters. There's 100,000 milliliters in a hectoliter. Okay. Okay, let's go to the conversions here. Okay. 1 meter is equal to 1,000,000 micrometers. 1 meter is 1,000 millimeters. Kind of already knew this. 1 meter is 100 centimeters. 1 meter is 10 decimeters. 1 decameter, okay, is equal to 10 meters. 1 hecto is 100, and 1 kilometer is 1,000. And 1 megameter is 1,000,000 meters. Megameter. Okay, let's see what we got here. Okay, so we want to convert 7,225 centimeters to meters. Okay, well, that's not too bad, because I know that 1 meter is equal to 100 centimeters. So I'm just going to divide this by 100. That means I'm going to move the decimal over twice. So this just becomes 72.25 meters. Okay, 32.5 kilometers to meters. Well, this is 32.5 kilometers to meters. So I know that there is, for 1 kilometer, there's 1,000 meters in 1 kilometer. I'm going to multiply this guy by 1,000, which means I have to move the decimal three places the other direction, or just say, hey, look, what's 32 times 1,000? Well, that's 32,000. Okay, so this is 32,500 meters. Okay, we'll move the decimal 3 times. Okay, 5,425,119 micrometers. Those are really small, to megameters. Oof. Okay. So 5,425,119 micrometers. It's a Greek letter mu there. Okay, micrometers. Okay, well, I know that there are a million of those micrometers in 1 meter. Okay, so 1 meter. So I would divide this would give me it in meters, but then I have to go all the way to megameters, and I know that we want megameters. I'm going to make that a capital M, megameters. Okay, and I know that in 1 megameter, there is 1,000,000 meters. Okay, so I'm going to have to divide by 1,000,000 twice. Okay, so let's go to the calculator on this one. Okay. So I've got 5,425,119 divided by 1,000,000. Okay, is 5.425, but then I got to divide that by another 1,000,000. Divide by another 1,000,000. And that becomes 0.0, or how many zeros? 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5 zeros. So 0.00005425119. So that's the megameters. Okay, a very small amount of megameters in 5,000,000 micrometers. Okay. These micrometers are tiny.
Can you walk us through that one again, please?
Sure. So there's 1,000,000 micrometers in 1 meter, and there's 1,000,000 meters in 1 megameter. Okay, so 1,000,000 meters in 1 megameter, and there's 1,000,000 micrometers in 1 meter. So I'm using the meters, okay, as the bridge between the micrometers and the megameters, which means I have to convert the micrometers will be divided by the micrometers here, and that would mean 1 meter. Okay, and then to go from the meters to the megameters, I'd have to divide by 1,000,000 as well. So each time I'm dividing by 1,000,000.
All right, got it.
Sure. I'll stop my sharing for a second. Hopefully it catches up. Well, why is this on Wi-Fi? It doesn't make sense. Okay, there we go. That should be better. Okay. Okay, hopefully that's better. For some reason, my laptop was on Wi-Fi and should have been on the Ethernet cable, so hopefully that'll fix the lag. Okay. Okay. If you have a prescription for 5,000 milligrams of medicine, and upon getting it filled, the dosage reads 5 grams of medicine, did the pharmacist make a mistake? Well, you know what's 5,000 milligrams in terms of grams, right? So, okay, so we want to change this to grams. Well, 1 gram, how many milligrams are in 1 gram? Milli means what? Means 1,000, right? Milli is 1,000.
Yes, yeah.
Right? So this is 1,000 milligrams in 1 gram. So if I divide 5,000 by 1,000, I get 5 grams. So no mistake was made. You just can't have 5 grams as your answer, because that's not answering the question that was asked. They asked, was there a mistake made? And you say, no mistake was made. They're equivalent. Okay, 1 boxer weighs 85 kilograms. He has 80 dags, okay, or decagrams, heavier than his opponent. Excuse me. How much does his opponent weigh? Okay, so he's the heavier one at 85 kilograms, right? Okay, so we find out. Okay, let's change these. Let's change all of this to grams, and then we'll convert back. So 85 kilograms is equal to 8,500 grams. Does that make sense? Or sorry, 85,000. Sorry, 85,000 grams. Okay, 85 kilograms. Okay, what's DAG stand for? Well,
Decagrams? Something like that.
yeah, it's the DA is the deca, which is 10 grams. So DAG, 1 DAG is equal to 10 grams. Okay, 1 decagram, this is decagram. Okay, 1 decagram is equal to 10 grams. Okay, so how many grams are 80 decagrams? Well, just 80 decagrams is equal to 800 grams. Okay, so so since this guy is heavier, are we going to add the 800 or subtract the 800? Since the 85 kilogram guy is heavier, are we going to add it or subtract it? Well, we would subtract. And this would give me 84,200 grams. And what can I do to change that back to kilograms? Well, I would just divide by 1,000. Okay. And so this is going to be 84.2 kilograms. Okay, dividing by 1,000. Okay, so we changed everything to grams so that we could, evaluate this. And then at the very end, we changed back to kilograms. Why did we change back to kilograms? Because that's what we were given. Okay, we were given the weight of a boxer in kilograms. Okay, and so we had to change back to the original unit that we were given. Okay, 5.15, a 2-liter bottle contains 87 centiliters of oil. 2-liter bottle contains 87 centiliters of oil. Okay. So 87 centiliters, 7 centiliters of oil, and 4.1 deciliters of water. So 4.1 deciliters of water. Okay, deciliters. How much more liquid is needed to fill a 2-liter bottle, right? 2 liters. Okay, so we want to compare all this stuff. Okay, so we need to add this together, and then we want to find out how much more do we need to fill a 2-liter bottle. So it might be good to change all of this into liters. Okay, or we could actually change this all into, I don't know, liters is fine. Okay, liters is fine. So what's centiliters in liters? Well, 87 centiliters. Okay, how many centiliters are there in 1 liter? There's 100 centiliters in 1 liter. Okay. So this is going to be 0.87 liters. Okay, and then how many? 4.1 deciliters. How many deciliters are in 1 liter? Well, there's 10. So this is 1 over 10. Deciliters is a liter. So this is going to be 0.41 liters. I'm going to add that together. Okay, and I get 1.28 liters. Okay, 1.28 liters. And so how far away am I from the 2-liter bottle? How much more liquid is needed to fill the bottle? Well, let's take 2 liters, or 2.00 liters, and let's subtract off the 1.28 liters. And when we do that, I get 0.72 liters. 7.2 more liters. 0.72 liters more are needed to fill the bottle. Okay. Question on that? Are the notes on Canvas? The notes are on YouTube. So just to let you know. Okay, so that's all of chapter 5 that I'm going to cover. Okay, so we'll just call it a day there. If you have any other questions, let me know. I'll be uploading this to YouTube as soon as it downloads onto my computer. Okay?
Thank you so much, and I appreciate you going slow
Sure.
for today.
I have a question.
All I heard was somebody saying, I have a question.
Professor, I have a question.
Yeah, I can barely hear whoever that is talking. Let me see. Who is that talking? Let me
If I'm correct, that was Paula, but she's probably now typing it.
Okay. Can you hear her, or is it just me?
It's a bit choppy.
It's hard. It's pretty. To me, it was pretty faint. I meant this worksheet. Oh, the guided notes? Yeah, the guided notes are on there. They're in every module. The guided notes should be. It says Lippmann guided notes. So you just download them every class session. Okay. Does that answer your question? I can show you where they are right here. If we go to modules, boom. Okay. Module 5, right? So Lippmann notes right here, boom, just download those. Every time you see these notes, that you got to have these prepared in advance. Okay, each week. The modules go by week number. So module 5 is week 5. This is week 5. Okay. If you ever don't know what week we're on, just refer back to the syllabus. Okay, the syllabus will tell you what week you're on. Okay. So right here. Okay, so week 5 is right here. And it tells you, oh, we're going to be covering 5.1, 5.2, and 7.1, 7.2. Boom, there you go. Okay, any other housekeeping issues that we need to take care of? Okay, I'll see you guys on Wednesday then. Bye.
Thank you. Bye-bye.
Are we not going to go over the last page, Professor, the temperature one?
No, that's not on the exam.
Oh, all right. Thank you. Bye.